Thank you for coming. I'm Chris Nash. So I'm going to be talking to you about two projects, Klang and rapIDE. They're both aimed at making audio programming more accessible without compromising any of its power, portability, or performance. Because a lot of what I do is about teaching, and it's usually about teaching non-programmers, especially musicians and artists. So here's the plan. Plan is in inverted speech marks. I want this to be a nice informal session. I want you to disrupt, ask questions, offer counter opinions. This is at the welcome stage. So I wear many hats. I'll talk about my background in a second. Can I see a show of hands how many C++ developers are in the room? Right, yes, well, there's always going to be a loaded question at this conference. Is anyone new to programming? Is anyone, they're all in the first Juice plugin workshop, I'm guessing. But we will be making plugins, and if you are new to it, don't be afraid. That's the whole point of these technologies. There's a lot of stuff in front of you in terms of, this is going to support the exercises we do later. But don't be too scared by them. Some of it should be familiar. Also block diagrams on the back. I'm going to spend about 25 minutes giving you the context of this project, talk about education, talk about the profession. Again, please volunteer your thoughts and opinions. There will be time for discussion as well. Hopefully there'll be some thought-provoking points raised in this session. So I'll talk about the relationship between academia and industry. I'll talk about this lofty goal of designing technologies with low thresholds, high ceilings, wide walls, and many paths. And I'll talk about a couple of psychology concepts. So I briefly talked about them last year, but they're quite important in trying to make something alive and expressive if you talk about how the user thinks. And, we're trying to make them happy, basically. Then, hopefully, pretty quickly, I'll get on to talking about the projects. I'll introduce you to the Klang language, which, spoiler alert, it's actually C++. But I'll also talk about the other half of the project, which is rapIDE. So that's rapid audio prototyping, interactive development environment. So the idea here is that we have a C++ IDE inside a DAW plugin that can build inside your creative process, or maybe it's a development process where you can change the code and listen to it instantly. So there'll be a language primer. I'll do some demonstrations, give you a tour of the studio itself. So for the hands-on part of the workshop, you will need to download the software. It's a single download, so go to, the website will be up when we need it. But if you have already downloaded it, there was a new version for Mac released last night. So you probably want to grab that version. You will have a chance to do that again. This is technology that's under development. So if you don't like something, say so. Because you've probably got a good idea, okay? And I'm designing it basically for you. So if anyone wants to be involved, please let me know. Then we'll have a brief 10-minute discussion before a break, which is coinciding when there'll be actual food and coffee outside. So there'll be just a short break before we actually get stuck in, and we'll start making some synthesizers and effects. So the stuff that we can make is actually in front of you. So you've got 4 cards. One of them is the subtractive synthesizer is just an example. It's got the block diagram on the back and the code on the front. And then the others are part solutions. So we'll get to that in the second part. Hopefully by then you'll realize how easy this all is. And actually, given that most of you are C++ developers, you're probably going to find this harder because you're probably going to think it's harder than it needs to be and overthink it. There will be a chance for open exploration. So again, you play around with the technologies, explore it and how you'd like to use them, perhaps. But there is also in front of you a feedback form for the technology and for the workshop. So I'd really like to know whether this is something that's useful to you, basically. It's anonymous. but there is a strip on the back where you can leave your contact details, and I'll be in touch if you want to get involved. That bit is removable from the rest of the form, so it is anonymous. Plan to end at 5. It might be the start of a lot of conversations, hopefully. So the next stage of the workshop continues in the pub. I'm from Bristol, so I teach here, and I develop my software here, so I know the town very well. So if you want to know where the best restaurants and pubs are, I'm also good for that. So who am I? I wear many hats. I think probably the developer should be first. I consider myself an audio developer first and foremost. I worked for Steinberg. I've led projects for the BBC and various things, a lot of startup consulting and things. But I wear 2 other hats as well, and that's one in academia and one as a composer. So I've got a perspective that is both the user's perspective, the technology maker's perspective, but also the educator, okay? And I've been teaching C++ to musicians for 10 years, and it's getting harder. So I'm going to talk about some of those issues, but one of the things I want to talk about is who's in academia in the room? Rehabilitated, yeah, out on parole, yeah, cool. And who's in the profession? Okay. There's a disjunction between the two, never the twain shall meet. So this is what I try to do. When I'm working in academia, I try to look at research that is relevant to the mass audience of our technologies. So the people who are into popular music, not art music, the people who are trying to make money out of music, the people who code in C++ rather than Max or SuperCollider. And my courses try to feed the industry. So I teach on two degree programs. So I teach at UE here in Bristol, the University of the West of England, and you'll see a lot of our graduates floating the halls. They have gone on to work for Juice because we actually teach C++. And I now also work for Point Blank Music School in London, where we're starting a professional audio degree program. So this is 3 years with the purpose of basically making more of you guys and girls. In fact, a lot more of girls, hopefully. And yeah, everyone else. But it's designed to kind of tackle this issue we have with teaching C++. It's designed to widen participation, but it's also designed to get people who are not non-coders, and at the end of the degree, they're working with the state of the art. Right. So, how do we make learning enjoyable? Well, people have to want to learn, okay? So we put them, what we want to do is put them in the flow state. And we've all probably been in the flow state at one stage, which is where you're totally absorbed in the activity you're doing. The rest of the world ceases to exist. You feel in control. You're not judged by anyone. No one else exists. Time flies. If challenge is too much for your ability, anxiety. Here lives C++. If the challenge is insufficient for your ability, boredom, okay? This is where Scratch lies. Scratch is great for supporting you at the start, but when you'll outgrow it effectively. So we don't want to learn a technology we're eventually going to outgrow. And if you want to be in the industry, you probably want to learn C++. So how do we get to C++ at this level when you start with no ability whatsoever? So a lot of my researchers looked at this. Please read my PhD and papers. But the key thing, we've got to match challenge and ability, okay? C++ and IDEs present too much challenge for the abject beginner. This other one, feedback, really, really important as well. So it says, how quick can you get feedback on the stuff you've just done so that you know what the results of what you just did is, okay? And, with build lengths and build cycles, it can be a long time before you work half an hour on a piece of code, click build, and it doesn't work. It can be awfully deflating. I'm sure everyone's experienced that in this room. But if we had a really fast feedback cycle, it's great for learners. Just want people to focus on what they're doing rather than worry about anything else. Feel in control and ultimately enjoy making DSP and plugins for their own reason. How do you know you're in flow? Well, if you realize you're in flow, you suddenly break out of it. But if you realize it's suddenly 4 a.m. in the morning, you've probably been in flow, okay? So this concept of feedback, so how live is the thing I'm working on? Okay, if I'm coding a plugin, how long does it take for me to listen to what that plugin can output? And there's a lot of different things that influence that, how build cycles and things like that. We can think of a block diagram as a representation of a plugin. It's not very live at all because we can't run it. Okay, we can think about it, and we have the literacy to understand it. We can see that that is a wah-wah effect. Okay, and we can build code. Okay, but there's quite a slow kind of feedback cycle. We have to build it, wait for it, maybe go make a cup of tea, run it, it crashes, reflect, go back to the code. But we also do have more live programming environments, such as live coding, supercollider, and so forth, which are instantly interpreted. Unfortunately, interpreted languages don't tend to be as fast as compiled languages, so there's the trade-off there. And there is always a trade-off. The more live you make something, the less abstract it can be, the less expressive power you have as well. So Max is obviously great for live performance. And when you try to make things complicated, they become complicated, okay? Here's a non-programming example of a live interface. The violin, okay? Stream-driven, really live, real-time, but it's real-time, so you can't abstract time, you can't compose loops on things like that, you can't compose generative music, unless you're at 9 and someone's added that to the violin. So a lot of my research basically looks at accelerating these feedback loops, and specifically when we're interacting with music, and the feedback loop we have in music is mediated by notation. So I've looked at how DAWs work, and I've looked at the programs that support really fast feedback cycles, Ableton Live, FL Studio, all based on short clips of music where you get fast feedback. Sound trackers, anyone remember those? Yeah, very, very fast. You basically write a note, listen to the note, write the next note, listen to the next note. So what we want to do is have this feedback cycle really fast with both the music and the notation. Right, so C++, hopefully, some opinions in the room. Who likes C++? Good, good, you're in the profession, so I bloody hope so. Stockholm Syndrome, yeah. Who doesn't like C++? Anyone who grudgingly uses it? I could ask a similar question about Pro Tools, but that's a different talk. Whatever your opinion, it is pretty much the industry standard. Okay, and that's why at least this half of the room all seem to be C++ developers. It's fast, it's efficient, it's portable. There's a lot of extant code out there. A lot of people are doing it. They can answer the questions. There's a lot of learning resources and things like that. It is, the MIDI of the programming language world. It will never die. It's also very good because it's a bit like the English language in the world. It's a bastardized language. Okay, it's a mongrel language, which is basically that language over there has a really cool way of doing things. Let's steal it. So C++ changes all the time, and it's very, very adaptable. So let's think about, in terms of kind of learner's path or how you get better at C++, what aspects and properties are relevant to this project. It's got that abstract, extractive power. The object-oriented nature of C++ really allows us to make complicated systems. And actually, we can make complicated systems easily. So the wide walls aspect of low threshold, high ceiling, wide walls and many path, tick. It's general purpose. It's the industry standard for our industry, but also a lot of other industries. Okay, and that means it's not designed for audio or DSP. It's just good at it by luck. But that does mean when you're learning it and you're learning a general purpose language, the goal of using it for audio is not clear, okay? There's a lot of distractions and other paths you can follow. The semantics are complex. You've got to learn a language. It's famously not a great language to have as your first language. Who learned C++ as their first programming language? Oh, actually quite a few people. Anyone who started out with something else like Python or BASIC or... Okay, but a few more. Yeah, cool. But it's like learning a language, and it's like being in a lesson where someone says, we're going to learn the grammar first, and then we can go to the country and have fun. Okay, when we teach code in universities, we spend a year learning C++, and then we make synthesizers and effects and have fun after that. It's like a rite of passage. The tools we use to write C++ are also very, very complicated, okay? And they're amazing. They're absolutely incredible, smart. They have thousands and thousands of features, and for the most part, they're completely free. Amazing, right? Not a problem. Well, you know, my students can't even install the damn things, okay? And then there are thousands of features that they don't need, which are scaring them, okay? Who here knows what every feature in either Visual Studio or Xcode does? No hands, okay. So it's more complexity there. So that's raising that entry threshold. It's style agnostic, i.e. you can write bad code, good code, flowery code, impenetrable code, nice prose in C++. So you can chart your own path. There's a lot of different ways to learn it as well. There's a lot of different areas you can use C++. So that's great, but it does mean that there's, gremlins and dead ends along the path, okay? And generally, it's quite low liveness. And so we write, and it's the example I told you about. The compilation stage basically means we're always waiting before we see the effect of what we just did, okay? And as a learner, that's critical, because it means that while they don't know what their code is doing, their uncertainty and anxiety is building up, okay? And when they see what happens and it works, it dispels. And when it doesn't work, it's really important that they haven't invested too much time into it so that they don't feel deflated. Okay, so high ceiling but high threshold. It's possibly what we should expect from the industry standard and expert tool that's used for a very hard branch of computing. Okay, let's switch over to the educational context. So as these technologies are getting more complicated, the digital literacy of young people is falling. Who thinks that's counterintuitive? Who's surprised by that? Or who thinks that's what I've seen. So who agrees with, young people today know less about computers than young people 20 years ago? Who disagrees or or intuitively would go the other way? Yeah, intuitively you'd say the generation that grew up with advanced computers knows how to work advanced computers, and they do, but they don't know how they work. Because advanced computers are smart devices and their workings are hidden now. So the actual devices and the usability obviates learning, it prevents learning. And so I actually get university students in a computer science department who don't know what file paths are.
That's a good thing.
Yes, it's possibly a good thing. But why is it like this? I mean, they've never seen them. They use controlled ecosystems like smartphones, tablets, games consoles, and web apps, and that's how they use their computers. So they don't actually know what's going on behind the scenes. And so when I'm giving them the chance, or the kind of, let's learn C++. Oh, wait, you don't know what a file is. Okay. But it is definitely something that's gotten worse in the last 10, 15 years. Okay, and that's weird. It's plugged in. Unless that's not plugged in. That wasn't plugged in. See, one of my students couldn't have solved that problem. So again, we've got this classical style of education. We'll teach the theory, the syntax, and the language, and then we'll do the good stuff. But we also have a young generation that doesn't go in for deferred gratification. They want instant gratification, and they need to know why they're learning something and why it's valuable to them, especially if I'm trying to teach a group of musicians who all want to be producers that, no, you really want to be a C++ developer. They need to know that it's fun, it's powerful, that it's creative, and they need to know within the first year or the first week, ideally. And this is being manifest in the fact that students are dropping out of computer-based courses, not just in audio, but across the sector. So there's a real disengagement problem in computer science in general in higher education. And so it just means there's a huger gap to that entry threshold. And the result is, because a lot of universities are businesses, and they need to have students, and they need to have students stick around, computing is increasingly being removed from the courses that we associate with audio software development. Okay, those kind of computing music and things like that are not recruiting, or they're moving some of the content from the first year to the second year, or they're moving it out entirely. And it's happening across the sector because they need to keep their students. So we need to make audio programming more accessible, especially if we're going to stick with C++. This isn't a new theory. The idea that audio programming needs to be more accessible. There's a lot of projects that have been done around this area that we see new languages appearing all the time. Max is quite often a popular choice at universities for getting into DSP and programming and things like that. But there is that kind of, you learn Max, how do you step into C++? Rainbow might be helping a bit there, but it's still very much oriented towards this visual approach. It's exactly what Soul is designed for. It's to make actually an audio programming language that is not just designed for beginners, but does make programming more accessible, but is also just better for us. It's more concise, clear, easier way, more expressive way to express audio processes and fast. Doesn't seem to be, running the project still, unfortunately. And that might be because if you've got a load of C++ code, how do you start using Soul? How do you integrate it with your projects? Faust, fantastic. Another way of bridging from DSP and block diagrams into C++ code. Yes? I have. Thanks, Dave. Yes. So there's exactly the same kind of problem it's trying to solve, and actually does a few more things better than C++ does. So all power to it, basically. But we're working in the same problem. My solution, since C++ I'm cynical and I think it will still be around for a long time, is to do this in C++. Is to make C++ more accessible. Because that's one of the other characteristics of C++. It's highly adaptable. So you can actually more or less write new languages in C++ just by overloading operators and messing about with it, basically. So that brings us to the first question. The question I posed last year, what if C++ had built-in audio semantics? And that is what Klang's all about. So Klang is 100% C++. It is a single header include that contains all the language, all the objects, all the primitives that you include. Then you include the namespace, and then you can start writing DSP processes like this. So a lot of the code that was boilerplate code is just hidden away in superclasses, okay? But one of the key things is we have this kind of explicit support for signal flow in C++. And so what effectively I've done here is overloaded the stream operator. Because it's arrows, it's directional. We kind of know how to use it. And what happens is that you move it, basically, you can have a block diagram, maybe on the next slide, and you can have objects that are times by other things in exactly the same way they would be in a block diagram, but also flow into other things in exactly the same way as a block diagram. It's designed to be lower threshold, because it's, first of all, it's more concise, but it's also speaking the language of audio processing. The idea, the goal, is for this to be a kind of pseudocode-like way of writing audio programming, but one that is fundamentally C++ and executable. It's a high ceiling. Because it is C++, you can liberally mix any line of C++ code in there. Within a line, you could mix C++ code. Yes? I haven't combined them together. I have done some programming in that. Yes, so definitely namespace collisions and things like that are a bit of a headache insofar I've only come across them with maths processes, but I think I'll cross that bridge when I come to it. But I do anticipate there to be bumps along the way. Right, this is a language, right, and it's C++, so it can be used in any way that you normally use C++. You don't need a special IDE or anything like that. You can use it in Visual Studio, Xcode, embedded systems, it'll compile to WebAssembly, whatever. So it's compatible with existing code bases. You can put a little bit of your project in there. It doesn't have that kind of, oh no, you have to embrace Klang fully to start using it. You can do it a little bit, you can do it for little projects, and there's instructions on how you might, integrate this with Juice and so forth. Yes?
So it's interesting you call this a dialect.
Yeah.
Not a library. I would look at it as a recruit and say, hey, nice library you got.
It's a library, but what's the idea is to change the language. So I think the formal name for it would be an embedded domain-specific language. So domain-specific language is a language designed for a specific task, and embedded means that basically it's just been put on an existing language, so that it has all the basically interoperability with an existing language, in this case C++. So yeah, this is the language, okay? Here we go, here's a block diagram and the equivalent Klang code, okay? And you can see that you've got a modulator, which is running at 3 Hertz, halve the range and add it. So you can see the parallel between the block diagram and the C++ code. And the signal class is a really simple, lightweight class. It actually is not, it's got not a virtual table or anything. When you build it, when you compile it, all of that stuff gets compiled out. And so it compiles down to just as if you'd written floats. So it's designed to be very lightweight, to be almost the same way we do in C++, but just a wink and a nudge towards block diagrams. Here we've got the input, goes into the filter, which is being modulated, goes to the output. As C++, it compiles as C++. So just briefly, it's free, it's open source. So if you want to give it a go, it's just the single header include. Please give me feedback and things like that. We'll be obviously using it in this session. But the goal of it is to take advantage of that expressivity of the language, which is to come up with a repository of reference DSP implementations, the like you might have on musicdsp.org, but in a kind of pseudocode which just happens to also be executable. Right. Awesome. I fixed C. That's it. Pub? So no, as I said before, C++ is only half the barrier for students because the IDE is also somewhat scary, okay? So the other question I'm trying to tackle is what if we could actually do our coding and our learning inside a more familiar environment, a more creative environment, inside the digital audio workstation? What if a plugin was also an IDE? And that's exactly what rapIDE is. So rapid audio prototyping, interactive development environment. You load it up and it is just a plugin, okay? It's either a synth plugin or it's an effect plugin. You use it as such. It's C++ running, native speeds. You can do anything you like with that. It has the same ceiling as C++, but then you just can also expand it, and you realize there's more to this plugin. There's analysis, there's some test files, there's some sequencing, and then there's this button which says Edit C++. So in the plugin, you can edit the C++. Okay, the code of the running plugin, and then click build it in the background, and then hot swaps it out without you having to restart the host or the plugin or anything like that. And what this does, then the main thing is it reduces the feedback cycle. So you can literally think, well, does that work better with 0.6 or 0.7? So I'll try it with 0.6 build. 0.7 build. I mean, you could obviously make a slider and do things, but you can edit the UI. You can write in either Klang, C, or C++, and it's just designed to accelerate that feedback cycle. But it's also designed as an audio IDE. Okay, not a general purpose IDE, but with analysis, audio tests, and debugging. So it's got live debugging as well. You can stop the running plugin, have a look around, look at all the variables, and nothing you don't need. Okay, so it's ideal for students. It's also a lot easier to install, even on a MacBook Air with 120 gigabytes, because it's 100 megabytes. And the toolchain behind it is still the same Klang, LLVM toolchain that you get with Xcode. So you're still producing the same professional code that runs at the same speed, but it's just there. Everything you need is easy to get going. I found designing the demos and the examples and things like that, obviously trying to make them sound cool, I was thinking a lot more about what the sound was than what the code was, because I was that much closer to the sound. And because it was so quick to try ideas, I could ideate more. So I'm actually thinking this is great for students. Hopefully this is useful to professional developers. It's great for engineers, hopefully, to communicate with. But maybe also, people who would have used things like Max for sound design could start trying C++. It's got lots of other things built in. It's got the analysis. It's got graphing tools. You can plot a transfer function. You can capture an impulse response from your plugin and present it. And we'll go through all of those. But the key thing here is the liveness and that feedback cycle. And to a certain extent, it's also about the safety of it. Okay, what's the worst thing that can happen? Well, if I'm running everything inside the door, I guess the worst thing that can happen is I crash the door. Yeah. At the moment, it's orientated towards simplicity, looking at the kind of accessibility and educational uses, but I would totally want to support more involved projects. I also don't want people to get trapped in the box. So if you start prototyping something here, I don't want that to just be prototyping code. I want that to be useful as production code. So there'll be export as a juice project. There'll be export as whatever. Export as a VST plugin. And there will be some form of file management as well. If you were to include, say hashtag include another file, it will take note of that. At the moment, you can't add extra object, CPP files in there to target the compiler, although you could hack that just by putting include in the CPP, but I'm going to make that a lot more scalable to more professional and complex projects.
If I open it in VS Code, because I like
Mm-hmm. Yes. Yeah. So if you're working in Klang, I've decided the thing about the conciseness of Klang is that you can do a lot more with a single file. So it basically, the standard model is just to have a single file, which is a .k extension, but it's really just a C file. So you just give that to the C compiler. For the others, they're all standard CPP and header files. They do exist on your hard drive. So they exist in your documents folder, basically. So if you install the program, in your documents folder, there'll be a Klang projects folder. And then if you look in source, SRC, all of your projects will be there with their name. And so, yes, you can take that into VS Code or wherever you like, basically. But I want to basically, because in the pedagogy, this is how I'd introduce it, but I definitely want to teach them Visual Studio and Xcode. So I want to be able to export from here so that you can start here and you bootstrap the process. You make it fun, you make it interesting, you see what's happening. Great tool for prototyping too, but if you want to raise that ceiling and you can use all the professional tools as well. Right. Let's have a look. So here we are. And the sandbox is doing a very good job of demonstrating how it's keeping the door safe. This is just a plugin. It's running at the moment just in a simple Juice plugin host. And yeah, so this is from an earlier demonstration. So let's start something new. We call this ADC, Klang. There we go. It's generated a new project. It's given you a template, a starting point. This is the effect studio. So this is an effect. It defaults to 2 in, 2 out. But it's a mono effect. If you want to make it stereo, you just change that over. So that's one of the exercises. We'll be doing a ping pong delay. But yeah, I just hit build. The LLVM toolchain is used in the background. And there we go. It automatically updates the running plugin. If I want to add a dial, there you go. Flibble. Pretty straightforward, but the feedback cycle is the key thing. That flibble obviously doesn't do anything at the moment. We could make it do something, I suppose. We can make a delay. So Klang also comes with DSP primitives so that you don't have to roll your own until you're ready to. So if you want a delay, we'll make one. I give it the maximum size of the buffer, and so it goes away and allocates that. I'm going to be imaginative and call it delay. I'll have Flibble controlling the delay. So we go down here, and we go put the input into the delay, and then maybe we'll have the in plus the output of the delay times gain, and we need to give the delay its time. So we'll get that from the slider, which is controls 2. And then we literally just configure it on the fly. It's expecting it in samples, so we'll times it by the sample rate. And there's a lot of helpers and things like that built into the header. So for example, a lot of pre-calculated constants. So if I want a double version of it or an integer version of it, the calculation has already been done. You want inverse or you want to know the Nyquist. So it's all to make it a lot more readable when you write the code. In this case, we just need the sample rate. And I think that's it. Okay, if I put that, see if we can hear an echo. Oop, so it's plotting the impulse response. Oh. Right. You got some volume at the back there? Okay. So definitely the echoes working. Okay, if I want to make a feedback, then I just take the out and stick it back into the delay after it. Okay. So really, really easy to explore different ideas, and the relationship with the block diagram is also really clear. Okay. Various other things you can do in here include, say we had a simple hard clipping function. We've written it in just C. We can also stream that to the graph, and it will plot the transfer function. It's got other features in there. So if we, for example, that's nice and easy. We have one X and one Y, one in, one out. What if we have a shaping function that has multiple inputs, an X, but also maybe a C or an A or something like that? There's kind of constructions in there to allow you to plot that as well. So you can set one of the functions maybe to a slider and then interactively play with the transfer function. And it's just, for my students, this is great because they'll see in real time what the plots are and what they're doing, and it becomes a lot easier to teach other dimensions. Where's Al? What do they call it? ADC. There we go. Likewise with an impulse plot. So I can just plot that, maybe with some delay time. There's a longer impulse, and there you can see that. So a lot of things just there and easy to play with, great for debugging and so forth, but also just playing with ideas. Any questions? Cool. Right, let's hop back here. Absolutely.
What you're doing is exactly what we do about processing, but it's very efficient.
Mm-hmm.
There was another project that had that same objective.
Mm.
I'm wondering, probably you're aware of open frameworks.
Mm-hmm. Yes.
How does your work compare? How do you go off in a different direction? Take from that, work on that. I'm not saying there can be only one. I'm curious.
So the open frameworks and processing are about, they're big code bases. They support a lot of different things. And this is largely about focusing on just on DSP and a very specific use case and getting as close to pseudocode, how we might describe it to each other. A lot of this work grew out of the teaching over the last 10 years. And incrementally, I've got to this stage. So as a teacher, you make a template for the students and a project, and you set it up. And the first one we did was a core audio plugin in Xcode. And back then, students were okay with that, but then they started struggling with that. So we moved over to a Juice framework, and we simplified some of the things. And that was good. And it supported Windows and Mac. That was great. But people then began struggling with Juice and being scared by everything there. So I made it a bit more simple, added some wrappers and some things like that on there. And one of the interesting things about that was, even though I just made the project a little bit simpler, the sea change in the student engagement was incredible. I went from the assignments at the end of the year where you just say, well, take one of the practicals that we've worked on and see if you can incrementally add something to it. You must build something. It can be anything you like, but it must build on what we've taught you. And before, when the project was a Juice project and it was in Visual Studio and it was very, very complicated, we were getting we taught you FM, simple FM, and you've given us FM with two carriers or something like that. Still sounds very FM. And then once I made these slight tweaks to the IDE and the way they were interacting with it, that just meant they got started a bit quicker and things like that. Today, I regularly get DX7 emulators. And I didn't expect that kind of change coming from it, but it was just absolutely incredible. And it really taught me how important that honeymoon period is at the start, that first week or two. If you lose them then through any number of things, which could be as simple as I couldn't get Xcode installed in my computer, you actually lose them completely. They'll feel lack of confidence. They might have fallen behind. It's just, and there's lots of little things like that. So I don't know if that answers your question, because our open frameworks potentially could do that. But I would still be nervous about giving processing or open frameworks to my students because there is a lot to see there. Well, hopefully, I hope to do it well, especially if I get feedback and input. That'd be great. You had a question? Yeah. Oh, yeah. That's a good idea. Is this on? Yeah, it sounds like it. Cool.
So then,
Thank you, Maisie.
question would be, how would I integrate, say, some other libraries,
Mhm.
frameworks I have, and other things? Like I might have a whole bank of stuff. It's like, how do you keep it from becoming really complicated in managing all the different frameworks, libraries, tool chains? Like, at what point? And then also, how do you balance that?
Mhm. So that's where the separation of the two projects comes in. One is the Klang language, and the other is the kind of platform to develop in. And this is just an IDE. So the IDE is there to make the common case simple and to make the useful case simple. If you then want to integrate Klang code with a different project, or you want to bring in a different project or something like that, that's when you might move over to Visual Studio or Xcode or something like that. And it's early days yet, but you basically will go here in the kind of project screen, and there'll be a lot of different export targets. So this one, so these won't work at the moment because it's just in my version. That will make a binary plugin which doesn't have any of the editor in it, and it literally is just exactly the same as if you coded it in C++ from scratch. That supports obviously coding to WebAssembly, and it will give you, so it uses something called Wagic, so it doesn't rely on mscripton. It's completely self-contained and mostly just within the LLVM tool chain, plus working out what kind of JavaScript you need at the other end. So this is all basically gives you code that you can then do with what you like. So if you want to integrate it into a Juice project, there'll be instructions. There will be an option there, make Juice synth project from this Klang synth program, effectively. And it's about supporting those many paths. Yes. Is it not working? 1, 2. No, it doesn't seem to be. Is there a button on the mic? 1, 2. There we go. Right. There was a question over there. Yes, sir.
I'm very satisfied to hear about all the educational side of things. I used to be also a student for a long time. I also used to teach a little bit, and I think I would have liked to have this. But now I'm a professional, and I don't think I could use Klang if I could not integrate it, not as a VST plugin, but inside my source code, inside my source project.
So there's
so the part that I start to be curious about is all the connection to the audio streams and everything.
right. So there is, if you go to the GitHub page, the README there actually has a little section on how to integrate this with your other C++ projects. And effectively, it's got a layer above that where you just call out to start a note, stop a note, or effects or something like that. And so you can literally include Klang, or you can include the K file in your C++. So the code you've got here, if you include that, you get access to this object, and all you have to do is send it effectively floats. So the standard language of here's a buffer of floats, do your thing. If you don't want the objects, and say you're not writing a synthesizer, you just want to do some DSP, but you want to express it as a block diagram, also just including the Klang header means that you can use this interchangeably with floats. So if you have code that is currently running on a float basis or something like that, the signal is exactly the same. So it will just, you can use it basically, and you can pipe between floats and signals and things like that. So it should be as easy to pull that in, but you're absolutely right. At the moment, I'm focusing on the kind of pedagogical aspects, but I'm definitely very interested in that ceiling as well. So if you want to work with me to make sure it's a useful tool to you, that would be great.
And while I have the mic, why Klang?
It's a German word for sound. And so obviously it's a play on C-Lang. It's obviously a play on C-Lang, the tool chain. And I thought, well, I'm messing a little bit with C, so I'll change the C to a K, and now it's better for sound. I do get some friction from that because of the homophones, basically. So I'm tempted to rename it to K++. Dave.
What of this project?
Yes, so wait for the mic, sorry. I can repeat the question maybe.
Yeah, you might cover this in future, so feel free to wait. But I guess the other use case is rather than taking Klang code into an existing audio application is say I've got a bunch of DSP, like a filter class or something like that. Can I wrap it in a Klang object?
Yes.
Just so I can use it easily.
Really easily.
Yeah.
Yeah.
Okay.
Yeah, as I said, this is native C++.
Yeah.
If I didn't want to write that line in terms of streams and things like that, I could have written it just in C++.
Okay.
So even you can mix within a function, you could have a line of Klang style, a line of C++ style, a line of Klang style, not necessarily the greatest style overall, but it is that flexible because it is just C++.
Okay.
That's one of the strengths, I think, of it. And that's kind of it's what's difficult with some other languages like Sol is kind of like interweaving them and say, well, I have a really great code that runs optimally and I've optimized it and it's using Intel Intrinsics or Neon or whatever. Just stick it in here. It'll compile. Yeah. Does that answer your question?
Yeah, I think so. I'm pretty sure use cases are covered. I've got some other questions about safety, but maybe we'll get to those.
Cool.
What
Well, you know, let's go for it.
No, okay. Well, so the big advantage of something like C major or Sol previously was that they're kind of almost provably safe.
Yeah.
So when you iterate into a container, you have to specify whether you're going to wrap or saturate, and then everything's bounds checked. So even those numerical operations are safe. If you're compiling just as raw C++ and there's no additional like static analyzer or lint-in processors or anything, do you still have all those C++ memory safety errors? And how common are they that you run into, I guess, is a more practical question.
So it's a very important question, and it's relevant all the time, basically, especially for learners. Okay, the number of times I've given a DSP class and they've made a huge sound because they're listening to garbage memory and they're flinging their headphones across the room is ridiculous. So what is actually going on here is that the Klang compile code is running inside a shared library that the actual plugin is using, and that's why I'm able to swap out those code. At the moment, when you run in the kind of performance setting, it's running in the same process, and I'm using exception handlers basically. And it works extraordinarily well on Windows systems because you have some pretty advanced exception handlers that can capture almost everything. The one thing I can't capture is infinite loops, but which is the stopping problem. But and what happens actually, I mean, if you try to dereference a null pointer or something like that, as I think you saw at the start, it just comes up with plugin crashed. It turns out to be relatively, so here's exactly what I'm doing. I've intentionally put in a null pointer, which I'm trying to dereference and listen to. The exception handler, but then there are many exception handlers at different levels. When it called out to the library crashed and it basically caught it, and it just makes sure that, well, first of all, I won't output it, turn the bypass on, I'll crash it, I won't try to run it again. And when you try to build it, it basically, oh, I'll give it another go. And it won't actually continue until you remove that. And there is that element of safety because for a learner, you have to have a risk-free environment. But also as a professional, you have to protect your ears. So there is also basically range checking and things like that I'll put in there to make sure everything is between, not necessarily -1 and 1, because possibly you want a little headroom, but you certainly don't want it to be between 4 billion and -4 billion.
So it's kind of safety mainly introduced through the runtime.
That's right. So in kind of release mode, which is the default mode, you get what I call pretty good safety. When you hop over into debug mode, so it rebuilds it, it's actually running in a separate process entirely. Because the IDE is actually running in the doors process, I can't stop that process because it would stop the door and the IDE, which then could never restart itself. So even just to get this kind of real-time debugging, we have to spin it out to a separate process. And obviously, if that dies, who cares? But it does mean when I set a breakpoint, the door doesn't care, because basically I know I've set a breakpoint. I'm just going to return silence to the host and it will never be any the wiser. But it does mean you can root around and look at the different things inside it. Cool.
Yeah, that's very cool.
But I think safety is definitely an important thing, and kind of it's difficult. The Mac architecture is very different. That kind of system-based, high-level exception handlers are harder to get into because they're a bit more locked down.
There was a couple questions from online.
Okie dokie, fantastic.
The first one is, how difficult would it be to make a custom UI?
So that's an interesting choice. So Klang doesn't have any rendering code in it. It just basically you define what you want the IDE, the UI to contain. So I want a slider. You can rearrange things. So I think if I do something like this, if I put it 50, 50, 100, 100, you can move things around and lay it out. You can change the bitmap background, so which actually gives a surprising amount of customization. It's literally just a bitmap. And you can do things like group controls together. So if I just say, this group is called left. Not used to this keyboard. Let's make it have the auto layout. I'm going to copy that dial left. Let's pretend this was a delay. And it's a lot of kind of messing about with what C++ allows you to do. And this is either your most hated thing about the C++ language or your most loved thing about it. And let's just do. So what's there is basically, yeah, I made a. Oh. There. The other thing, so definitely when it doesn't compile, you'll get just the output of the compiler, which I have to say LLVM does amazing output and really helpful comments. But there's a lot to be done in making it more accessible from a UI point of view, like highlighting the source code and things like that. This is version 0.7. So. But yeah, so you can group things together. And so let me switch over to the synth and load up one of the examples. What do I call it? Subtractive modular. Let's build it. And so if you tell it exactly what you want, it'll draw it that way. But this is rapIDE drawing the interface. It's basically getting that request for a UI, and this is how rapIDE would interpret it. If you export it to WASM, your JavaScript code would also need to have the equivalent rendering graphics and things like that. That is stuff that rapIDE will supply in the end, but ultimately you can do what you like with it. So if you want a Juice plugin and you want complete control over the UI, do what you like, basically. Use Klang just for the DSP, it's up to you. But my attitude is kind of, I'll stick to that kind of minimal aesthetic. I'll try to minimize the skeuomorphisms and things like that and just focus on functionality. Because especially, I certainly find I love making those kind of UIs, and I'm working in Photoshop or something like that. But I will spend hours fixated by pixels when I probably should be just working on the DSP. Right. So that is rapIDE, also known as Klang Studio. I haven't decided which one I will go for. Maybe when it's Klang Studio. When it's C++, it's the other one. I don't know. It's available, so have a play with it. It's Windows and Mac. It's not open source. I'm thinking about it, but I have this dilemma, basically, is that I'm a non-profit organization, but I do need to stay alive. So I'd love some model where it's free for learning or non-commercial use, but how do you enforce that if you open source it? I'd love to open source it, but ideas on a postcard. Any ideas? Dual license, yeah. Like Juice, yeah. Yeah, it's certainly a possibility. I'm very tempted with kind of GPL, the stuff, and then say, if your focus right, you have to pay me, that kind of thing. But yeah, but basically, if you're interested, do get in touch. There are a ton of things in the works in terms of extending this and making it useful both for learners and for professionals, basically. And it is kind of part of what we're going to be doing on the Muse course, which is Music Software Engineering course in London, which is this is how we get you playing with plugins and learning a little bit of C++, without having to learn all of C++, and then you can do plugins. You do this, you work out why you're learning C++, then you've got the motivation to go on and learn the rest of it. It might mean that you leave Klang and rapIDE behind, but it's a stepping stone. And I'm hopeful, because I certainly find it useful in just kind of prototyping and exploring ideas and sounds. And strangely enough, a lot of the demos are kind of like I tweak a few things and I just go down a rabbit hole and just explore different things. It's a lot of fun. Here we go, let's give it a go. So this is exported to WebAssembly. Hopefully the sound is all it's good. Oh no, hang on, we have switched over. But apparently that should be the one. So yeah. Just accidentally discovering new sounds and things like new synthesizers. It was just fun. It's kind of, I feel a bit more creative. Okay, that's kind of the end of this section. I will just briefly, so this is the course in London. And it's a cornerstone of the first year, basically, to get someone from zero code to C++ within a year, given the current state of digital literacy. So this comes in the second module, and we teach them basic computational thinking with Manhattan, which you may have seen last year, but come out to the conservatory to have a look at, well, killing musicians, basically. So it's procedural music, so you're learning about computer science through programming pieces of music. Then we'll start DSP in Klang and so forth, and then we'll upgrade to the IDEs and Visual Studio and the rest of C++. So yeah, I can't actually believe it. I'm on time. That's weird. Great. So any questions, including about the wider context? Yes, please.
Yeah. So from what I understand, it's not really important which DAW you run this in. So another approach you could take is probably instead of, for example, use the Juice plugin tester to run this. Maybe you can take another approach where you create, say, a VS Code plugin, which will take care of the shell or the audio part. And that way you can utilize all the IDE-like abilities of Visual Studio. VS Code, which is...
And believe it or not, actually, when I started this project, I looked at VS Codium, the source code for VS Code, and to actually think, well, what if I adapt that to be an audio IDE? Part of it was I I'm not that up on TypeScript, and it was a sprawling code base. The other aspect of it is just I wanted a lot of focus and control, basically, and I think I wanted it to be a plug-in and a door. I'm definitely open to the idea of it being integrated in other pieces of software. So one of the things I might do is, rather than just release rapIDE as a kind of plugin, is actually release it as a component that you can include in your applications. So if you had a music app, for example, like Manhattan or my own DAW, it just has the C++ editor built in, not as a plugin, but as a kind of, oh, you can use this built-in sounds, or you can design your own. But I think, yeah, it's early days, but I am thinking about that kind of integration with other apps as well. In fact, I glossed over it just a little bit, but it was, believe it or not, that last item in the list there. But yeah, I mean, I do love VS Code. I think from my point of view, it's still quite complicated because for my students, because it's simpler than Visual Studio, but it's also rawer. It's you require a little bit more configuration. You've got to actually find config files and things like that. And given that my students don't know what files are, I don't know if that's necessarily solving my problem. Thank you. Yes. Ooh, yeah, let me. Beauty of long legs.
This is super interesting. I think you've outlined some context where you think where this is really useful.
Mm-hmm.
I was wondering if you have thoughts on where you would maybe not use this or where you don't think it's suitable.
I do worry about a lot of the things I do, and I think everyone does, especially if they come from academia, is that I've got this great idea, it will solve everything. And so I've, over the years, got really about narrowing your focus is really important and going deep rather than broad. So this is fundamentally, it could be used for any DSP. So there's another path I could go down. That we could do it. Here's an optics plugin or something like that. And I go, no, I'm just going to stay where I am. What shouldn't you use it for? I don't know. I'd like to hear what you'd like to use it for, or what you think it would be useful for. I think at the moment, you're probably not using it for writing a DAW, although you probably could use Klang. And so I'm gradually rewriting bits of this program in Klang just because it's simpler for me to reason about the DSP. I guess there's still a bit of lag, so maybe don't use it for live coding. Possibly there's a little glitch when you swap out. Probably fix that at some stage. But so maybe you can use it for live coding, but I don't know. What do you think?
That's what I'm curious.
So because of the two aspects of the project, Klang is supposed to be very general and useful in hopefully every kind of area, walk of life. And rapIDE is quite specific, and it kind of has special cases that I will cater for and develop and support, and others which are kind of like, if you want to do that, you can use Klang in Visual Studio.
Gee, one question would be, you brought up Faust before, and that's something where doing time domain signal stuff is great, but as soon as you start wanting to do FFTs,
yes,
it's a bit more of a problem.
Yeah, so at the moment, I haven't added kind of primitives for working in the frequency domain. I've got a student at the back of the room. He doesn't know it yet, but he's probably going to code that for me. Yeah, I mean you. Right. Yes, I mean, there's a lot going on there, and how far this translates. So you can, for example, filter topologies. Does it make sense to express that as a block diagram, which obviously you can, or is it make more sense to be a more mathematical approach, which is closer to the C++ approach? And the great thing is, because you can use them interchangeably, you can make your own decision. But teaching basic filters is good because you can do a simple LPF and APF and things like that just through the kind of routing and the signal flow, and then you have to start thinking about, actually, that's not easily visualizable. So in a language which is trying to be more of a visual declarative form of audio processing, when you want more abstraction, maybe maybe you need to switch it over to something else. Maybe GPU audio and massively parallel things aren't there yet. I don't know. But it is just C++, so I don't see any reason why it couldn't. But,
couple of quick questions. Firstly, on the process block, there's no general idea of like the number of samples, right? So
Yeah.
presumably when you create a signal, it's wrapping some internal representation of the buffers, right?
That's a good question, actually. So let me go back to a simpler thing. So what we have here, and maybe I'll make this a bit bigger. So this process is treating it as a single sample. Okay, and when I do teach DSP, you get a process block, which you get handed a buffer, and then you iterate through each of the samples potentially. This is just one mode in which it operates. So what's happening here is that there is also an overload like that. And at that stage, you can do buffer level processing. So it's basically because there's a default implementation of this that just loops and records this. But if you want to have really high performance code, then you probably want to be batch processing or vectorized operations or something.
Okay. And I know this is mainly targeted at students, so performance probably isn't your highest priority.
It totally is yeah.
Okay, but my business partner is Jules, so I'm quite interested in like the C major level of things. But obviously that all compiles essentially to a single function with a block of memory.
Yeah.
So it's kind of as fast as C++ could possibly be. Have you done any benchmarks to compare the code gen and how it compares with something like
I've not done any serious ones with profilers, but I have done some anecdotal tests side by side looking at the CPU meters.
Yeah.
And it's similar to C++, because ultimately it compiles down to more or less the same byte code. Because param and signal, they're secretly just floats.
It's more like the virtual dispatch stuff that I wondered if that introduces overhead.
So you get things like vectorization are all intact. I think auto parallelization, I have no idea. I haven't checked that kind of thing. I haven't started thinking about threading models or things like that, but I don't know that's something that C major is really good at.
Well, it's complex there, but
which is why
I was going to ask about threading, and I'm assuming none of the audio stuff is threaded, but is there like an async API for the events?
There is no built-in so the events are yes, they're thread safe.
Okay.
But that's largely because they're just handled outside of the. So yeah, it's just in the background, I think. That's part of rapIDE and how that does that. If you just in pure Klang, it's as dangerous as you want a C++ can be.
Okay.
So yeah.
I'm assuming your like event on and off are called by your MIDI handler processor, right?
Yeah.
So that's effectively on the audio thread, so it's safe.
Mm-hmm.
But if you can you define your own event handlers and then call to them from like JavaScript or something?
So I'll let you into a little secret here. Event is just void, but
yeah.
So they're just callbacks. So if you want to create your own, absolutely.
Okay.
And yeah, if you've got your own code which is calling out to this, you can create any kind of callback mechanism or threading model that you like, basically.
Okay.
It is literally just C functions that are called at the mercy of whatever's hosting it. And in this case, it's rapIDE, which is just kind of safety first rather than performance. But if you want, you could code any kind of threading model you want, actually, I think.
Okay. And hopefully one final quick question if I can.
Sure.
Obviously, you've been developing this to look like a different language.
Yeah.
Kind of. How close is it to your idealized language?
That's a very good question. And it's ongoing.
Right.
So actually, this is a great example here. So I did my PhD I did under Alan Blackwell at Cambridge, whose chief interest is programming language usability. And so we do a kind of cognitive dimensions of notations usability framework, which came out of programming language design. So I'm always thinking about closeness of mapping and progressive evaluation and visibility and things like that. But fundamentally, there are trade-offs. And there's two main pulls on my thing here. What I want it to look like, which is probably the model for that, is block diagrams. And to a certain extent, what that does is it drags it towards a declarative model of programming, which C++ isn't. Because also what I really want and need, that's actually an absolute requirement, is that this is native C++. So I am limited by what operators are overloaded and things like that. So how close is this? It's pretty close, actually, to what I like. But this ++ here is actually not in the language anymore. So if you read this, we have an oscillator scaled by the output of the ADSR times the gain, which is set via a slider. And the ++ was used to advance the envelope. Okay, and the reason for that is that sometimes I found myself wanting to reference it several times, and if I referenced it multiple times, I progressed it several times. So I thought I'll put in a ++ to make that clearer. And then of course, oh, doesn't that mean I have to put ++s in and all over the place, oscillators and anything that progresses? And yes, that was absolutely the case. And then I got later into my examples, and I had 3 oscillators being added together. So you had oscillator 1 +++, oscillator 2 +++, and little things like that basically you only discover in using them. And kind of like, okay, so how do I fix that? I think, well, do I put everything with +++, or do I have nothing with ++? Do I find some other symbol which says ticket? But what about if I want to just access it? And basically I went back to I killed it. And then when you want just not to process it, you just grab its out variable. Yep. And the rationale for these decisions is partly my aesthetic and partly where I want to go, but also partly which complex or nuances or vagaries can I delay until the student has been at it for 2 months. And because I don't want to introduce ++ in the first lesson, because that's just another thing they've got to learn. But then also, I don't want to cripple the language to make it less useful or more cumbersome for professionals. So there's trade-offs, basically.
This might be one for the pub later on, but I've been thinking about like upcoming reflection in C++, and I think that's going to kind of revolutionize DSLs. I think what you've got using C++ syntax gives you really first-class debuggability, and you can use all the existing tools. But I could see if you wanted like a different syntax, you could write it, reflect on it, and then just generate your existing C++. So
I stay glued to the changes in the standards and things like that. I mean, certainly, I think it's difficult to say which feature of modern C++ really enables this the most, but I keep coming back to initializer lists. And just the way it creates really, really concise code, even though it's something stupidly simple, and doesn't tend to have a performance impact. Does that answer your question?
Yeah.
Or is it enough to leave it for the pub later? Cool. Yes?
So
just one thing. When did I put the break in there? I don't want you to miss coffee.
I don't want to miss coffee either.
I don't want to miss coffee. No, we're good. We're good. Yeah. We're a little over.
Okay, so a question about thread safety.
Yes.
So thinking about it in the browser, I always think that we don't use enough of the compute. Like when that process guy is getting called, you're only using one core. But I might want to go ahead and have it spawn a bunch of things to do a bunch of calculations that I could come back later.
Yeah.
Are there thread primitives that you need to consider there? How do I access that out variable?
Yeah,
How do
100%.
I so
plugin frameworks and architectures are going to be multi-thread and thread safe and things like that. So it's no good me writing something that is only uni-threaded. I think what's interesting there, and I absolutely will be adding, concurrency primitives, hopefully in a way that makes them more digestible, shall we say, for my students. But I think the interesting thing that comes out of trying to make a declarative form of language is that you move over more to a statement of, this is what I want to do. And hopefully that means that you can make it a bit more adaptable. But I think one of the tensions is that this is still C++ and is immediate mode and float processing and things like that. What it isn't is a graph. And the graph would be ideal, obviously, for making parallel and multi-threaded. And that's something I want to avoid. The one thing I want to do is make automatic block diagrams and a visual thing. But yeah, it's an interesting question.
And because
I think you're good.
I'm gonna.
Last one before coffee. Yeah.
Okay.
I'll delay the restart, so you'll.
And so then now a separate one, which is declarativeness. You get a lot of declarative algorithms with ranges. Have you but this has been limited to C++ 17. Have you been taking a look to see what we can do with executors and ranges and those models?
I haven't yet, no, but I will. Yeah, I think. Yeah, that's all I can really say on that. I think I have a list as long as my arm, which is not actually that long, but of things I want to look at and places I could go. And I think some of these I'd really love help with looking at. And that's one of the main reasons for open sourcing it. And yeah, I think if there's enough interest, then what we do is we put a committee that kind of admits things to the language or something like that. But we can have, let's explore threading as a branch of this. Let's explore how this integrates with, I don't know, GPUs or something as a branch of this. Yeah, I mean, fundamentally, it does everything C++ does at the moment, and we just need to think about what more we want C++ to do, because it's the answer's the same thing.
What about Linux support? Or just private Linux, and I'm facing many issues.
Compile it with Klang, Clang, the LLVM compiler, and
the lib standard C++, I guess. Standard.
Yeah. Also, you need to tell it that it's C++ 17. That's probably the trick there. The side project is to get a Raspberry Pi version of this, basically, where you can develop it on the plugin in the door and then drag and drop it onto your Raspberry Pi, and it becomes a bit like Xinthian, an open source hardware platform. And again, that's to engage young people and say, well, I'm actually making a hardware synthesizer. But that's all Linux as well. And I have had that working, so it does work. Drop me an email and I'll, it'd be useful, for example, also to know the stumbling blocks. There's probably less of a priority for getting rapIDE working on Linux, but it is juice, so who knows? Right, and on that note, let's have coffee. And when we come back, we'll start getting some hands-on playing with Klang. If you don't have it installed or you're having problems with it installed, I'll be here throughout the break to walk you through it. And as I say, if you installed 0.7.2, there's a new version. The notable change is the new version doesn't have the ++ in it. So. Right. Everyone caffeinated? Yeah, ready for round 2. Some really great questions, some really advanced questions. Great to see some people already peeling back the source code. One thing that did come up, which is a feature at the moment, is if you're on a Mac. So on Windows, the entire LLVM Klang toolchain is built into the plugin. There are no other dependencies. So you just put the plugin in your system and run, and it's got everything you need. On a Mac, I haven't ported that toolchain yet to Mac. So we're relying on the Xcode command line tools to do that for us. So you do need to install those to have it run on a Mac. Fundamentally, if you click build and you get a plugin out of it, well done. It's installed. It's still quite good because you don't need to install full Xcode, so it's like 600 megabytes instead of 26 gigabytes. So again, it's okay for my students to install. But the plan is to replace it with a built-in toolchain. That is also a feature of the Xcode version, because the debugging feature is something I've added to the LLVM toolchain. Apple doesn't have it, so that's what's needed supporting, basically. I actually find that because of the feedback loop being so small, we don't actually rely on the debug mode that much. So it's quite interesting. And there are some other features that you can use to solve problems which do work in both environments, which I didn't show you, actually. Yeah, so everyone up and running? Anyone have any problems? Varies from platform to platform. Normally you have to, which one are you on? Your Mac? Let me just have a look here. It's Control and then 2 fingers up and down as if it was a scroll wheel. And that might work. Oh, the whole screen, I think, yeah. Right. So, yes, the built-in tests, which both of my students are probably having flashbacks on.
Expand the plugin UI.
Or
that one. Okay, I thought I had.
No, that's just the host. You can completely ignore that, actually. And then click Edit C++. So yes, when you first load it up, let me show you what it'll look like. It'll look like just a normal plugin. Okay, so if you load it in the door, it would look like your normal plugin. If there's no plugin that you've built before, it'll have a splash screen saying, "Hi, why don't you build a plugin?" Drag it to expand it, and then you can hit Edit C++ to get the code editor. If you want to kind of focus, you can maximize it. It relays it out a little bit. If you've got something like Reaper running, and you run it in the tray down the bottom, it'll detect that as well and put the code and the UI side by side. So literally having the code editor as a part of your door UI. Okay, one thing I didn't show you before, so this is probably as good a test as any. See if it works. It doesn't work. Oh, because I messed about with it. So to IDSR, oh, gain probably needs to be up. So in terms of debugging as well, one of the nice things about Macs is that you can pull a patch cable from anything and plot it. You get the same here. So if we think, okay, something's not right here, let's see if it's the ADSR. You can pipe that just to something called debug. Hopefully this will look pretty. And then you go back to the scope down here, and you can see the yellow is the ADSR value. And you can right click to get various options. If that's. But yeah, so it's just trying to make, those problems when you hit a brick wall and you don't know where it is, being able to pull your code apart a little bit more easily. Right, so in front of you, let's switch over to, you have several sheets of paper. So one is a reference card, and this is not just Klang. It is also those bits of C++ that my students might not know. So it is kind of a cheat sheet for C++, but also in blue, you'll see the kind of syntactic sugar that Klang adds, along with some examples. And hopefully, you don't have to revise this. There won't be a test at the end or anything like that. But it's useful to look things up. And I find it a really good teaching model, is rather than getting people to go through lines of, okay, now declare a variable, now set it equal to 0 and things like that. If you forced them to go and find the information, then that's a very valuable lesson for being an audio developer. Although they basically just go to ChatGPT. Right. The other thing you have in front of you are 4 cards. These cards have code on one side and a block diagram on the other side. Yeah. Does anyone need cards? Are we all good for cards? I have spares. Right. Start with the subtractive synthesizer one. Okay. I need cards. If you're online, the web address is nash.audio/clang/workshop/cards.pdf. And that should give everyone online access to the same cards. Okay, now where's my card? So the subtractive synth one is complete. This is an example, basically. So on the back, we all know and love the block diagrams. So there we go. Fairly straightforward, but decent enough sounding subtractive synthesizer. Does anyone want to go through what this is, or you're pretty happy with this, or have any questions about the block diagram? So if you now look on the other side, this is the code completed for that block diagram and that synthesizer. So this is just an example. Nothing really to do here other than to gaze at it and think, oh, that's amazing. But it does teach you some of the syntax and some of the kind of boilerplate code and so forth. So let me bring it up on screen. Maybe not that one. Here we go. So this is a synthesizer. So it's got 2 types of object, one representing a synthesizer and one representing an individual note. The note is defined inside and declared inside the synthesizer down here. And this is where for purposes of this session, we're going to be focusing our attention. We add 32 instances of it to the synthesizer, giving us 32 notes polyphony. And also the only other aspect of the synth itself is the specification for the user interface. Okay, and here we're just giving it a controls array, and we're saying that consists of a dial, which should be called attack, minimum, maximum, default, 0 to 1, and the default is 0.25. There are various other controls like buttons, toggles, menus, and things like that. For the most part, we just need dials for this exercise. But then we get down here, and this is what goes into generating the sound for each note, basically. So this is where we say, well, to produce a sound, we need a saw oscillator. We have a low-pass filter, a sine wave generator, which is going to provide our LFO, and an ADSR. I have imaginatively called them OSC, LPF, LFO, and ADSR, and they're labeled as such on the diagrams. So also on the diagrams, there's a kind of convention that if down in the process, I've defined a kind of separate signal path, and it's available as a signal, it's double underlined, basically. So those are kind of variable names, and the others are object names. All good so far? Excellent. Right, and then, we handle when the note starts and when the note stops, on and off. When you have an on, you basically have pitch and velocity, like any good old MIDI message. And the first thing we always do is convert note number to frequency. So here, pitch it's just a float, but I've given it the type pitch so that it knows what that float represents. Okay, a little bit of type context. And that means that I can use the arrow symbol and convert it to a frequency by literally putting pitch goes to frequency. And so that does the conversion. And that's what we tell the oscillator. Okay, that's what we did. If you set the oscillator, you can either just use brackets, so OSC in the brackets to set it up, or you can use OSC.set if you want to be a bit more explicit about it. But the good thing about that, it means is the short form you can use in line with audio processing code. So that's also how you might modulate variables and things like that. Right, then we just grabbed the first dial's value, stuck it in a variable called attack. Didn't really need to do that, but we set the ADSR up. It's very, very simple. Here we're using this .set. We could leave that out if we wanted to. ADSR. Yes.
That sort of pitch notation throwing me off there.
How the hell did I do that? And why did I do that?
How should you read it?
Mm-hmm.
Like, it's a teachable moment. Like, what does that sort of indicate when you're teaching your students what you say?
So this, currently when I'm teaching them, there's two ways to teach them this process that we need to do. We either give them the 44.0 to the power of the la-di-da-di-da, which I totally don't want to teach them. So then we move to a function that does it for us. And here I basically say, well, we know that this is a note number and the oscillator needs a frequency in hertz. So we basically know we need to convert it to a different value. And there's another basically smart type called frequency. And when you basically use that operator, it knows to convert between them and will return the frequency of the pitch.
So it's a set?
I think the mic's off.
So essentially, it's kind of a cast.
It's a yes. Yes. Have a look at the header file for the unholy way that I have achieved this particular syntax. Because there were various different ways that I tried this before. And this is clearly the most elegant. The only issue is probably that this is obviously a dereferencing access to a type, which is kind of what's going on, except that I've used a different, it returns a different type, and then that gets cast to the casting process, then converts between the types. Yes. So it's a lot of overloading again.
But there might be a sort of teachable thing for students who want, you're like, hey, you're going to go from here to C++. It could be possibly an overload could actually be a word like cast, or even a straight up static cast could be a way to say, hey, look, this is what I'm doing here. This is another way of writing it. You'll write this in the industry.
Yeah, absolutely. I think that's the beauty of C++ is that I can do this and I can have this nice syntactic sugar way, but there's no penalty for me also adding in a to frequency function and to have that stepping stone. The one thing I get nervous about is having this proliferation of different styles that then puts them in analysis paralysis and kind of like, oh, which do I choose? Is there a right way of doing this? And then they kind of do half the one way, half the different way. So in the first instances, I just want it to be as simple as kind of plain text pseudocode-ish as possible. And then later on, they can find, oh, we need to find a faster way or a more C-like way of doing a C++-like way. Yes.
So this conversion is aware of what sample rate this is running at?
It does know that. So the sample rate is available as effectively a global context FS, and so it will know that. Yeah. Good question though. I tried to also hide that until you need access to it, but you can obviously mess about with it. One of the things I want to do to extend this for more advanced applications is to have like oversampling, okay? But not oversampling with the kind of, it's complex and you need to set it up and you need to think about it, but maybe just as a language primitive or a kind of structure for doing it. Right, and so some of the idea is obviously if you can convert between different units and things like that, to have the conversion in there. Obviously, it doesn't work for some things. If you try to convert a pitch to an amplitude, it will just not compile. But you can convert amplitude to dB, for example, and you can convert dB to amplitude. So a lot of common things that we do that we would normally do with exponents or logarithms or things like that, but would make it less readable if we did. Okay. What do we have next? So that's all set up. And then we get down to the most important thing is the process function. And as you'll see on your cards, and if you've got someone next to you, maybe someone has the code showing and the other person has the block diagram showing. Because that's, it's nice to be able to see them at the same time. You'll notice that it's very, very similar in how it looks. This is basically the example from the slide, and this is the whole point of kind of the language itself, which is we have our modulation signal, which we've defined as a separate signal. It's an LFO running at 3 Hertz. We halve the output of it, and then we offset it so that it's not between -1 and 1, it's between 0 and 1, and then so it can be used as the coefficient for a filter. I think actually this filter, this code might be wrong, actually. You might need to change LPF to IIR, because I think LPF takes Hertz rather than a coefficient. So shouldn't kill anybody's ears, but let's see how you go. Right, so we've got the modulation there, and then like it says in the diagram, the ADSR is running. We've already set it up. It's a signal generator. We just times the oscillator and use the ADSR to scale it. Then that gets fed through the filter. But the filter is being modulated. So the filter cutoff is actually just the signal. So that's how you get signals coming in. It's how you solve the, okay, Max can route things and things like that, but this is linear code. And then to the output, okay? And so a very early version of the language had the output being the return of the function, but it's much, much nicer to have out being an actual explicit term. And for effects, you also have in. So you can just go in, goes to whatever, goes to out. And the performance penalty when it's compiled is negligible, basically. It's simple enough to get optimized out in most cases. The other thing that's going on there, this is a feature of synthesizers, and it's another thing I've learned from what do my students stumble at, is handling the end of the note, the release. Which is kind of like, okay, the key's been released, but the audio carries on, and the number of times my students then basically end up with infinite hanging notes. How do you make that simpler? I tried various different things, but here, basically, in the simplest possible thing, we could just have no release stage. And so if there was no off handler, it would just kill the note. And you wouldn't need any of this. You just run it, and it would produce the audio, and then it'd kill it. Only when you want to handle the release stage do you put an off in there. It gets rid of that functionality, says, right, continue audio processing. You don't need to tell it to continue. You'd say what it wants, you want to happen. I want it to fade out. Do the ADSR release. And then the only other thing you need to say is, right, we've taken possession of the audio processing now. We do need to tell it when to stop. And so we say, if the ADR is finished, stop the note, okay? Again, going for the most readable form for beginners, but this probably wouldn't be the first example I give a beginner. There'd be no envelope in the example. No, exactly. So most of the time you might have coded that, and if you made a mistake and it's still hanging on, it will be silent. And the only way you'd know it is because your CPU meter is way up the top, which tends to be what happens most of the time. Depending on if the note handling, you can also say, okay, you've run out of notes. It just dies. But obviously, if it's stealing the oldest one, which is what happens here, you won't notice that either. You just get a very bad performing piece of code. Plus, you'll hear it cut the note, if you can hear it, and it runs out. Yeah. This is how we do graceful death of a note, but it makes a huge difference. I'm sure we all know that, even if you just have a sine wave and you put an envelope on it, suddenly it's a synthesizer. It's not a test tone anymore.
In this case, how is the ADSR?
Right, that's a very good question. And that brings to basically all of these objects, when they're used in a context where a value is needed. So here we've got a mathematical expression. So this has got to become a number. That's got to become a number. That's when it triggers what we probably know in the STK terms as the tick, okay, or the process function. So basically, when you use it in an line of audio code, it progresses it, and that's when you get process. It does lead to the situation where if you were to say, mention it twice, it would process it twice, and you want to avoid that. And and obviously students are going to make that mistake because that is a mistake they always make. But you basically, when you just want to access what the previous output is, whatever object it is, just put the object name and dot out, and you'll be able to get, yeah, just exactly as we have here. So I'm using it for the audio processing here, but I also want to look at it without going faster. So I just get the out and I put it to the debug screen. Hi. Cool. Right. I think that is basically everything there. Any other questions?
Can you just wait?
Yep.
You mentioned before removing the ++ syntax for advancing each of those elements. Will they auto-advance themselves if you don't use them?
Yes. So I switched, that was just for envelopes. I switched that basically to the same model that every other object has, which is to basically auto-advance. If you don't mention the ADSR in processing and therefore it never advances, you run into another one of my students' problems with classic C++ code. If ADSR finished is never going to be true, you'll end up with hanging notes again.
And is that just referenced at all in the code? Like if you had it in a conditional, could you end up with a point where it would advance in one branch but not in the other?
So this expression here, this won't cause ADSR to advance.
Right.
Because basically you've got a reference to the object, then you're using a function within it. So basically what triggers it is when I cast it, when it needs to be casted to a float or a signal, that's when the processing is triggered.
Okay.
And this doesn't need to be cast. That's the kind of the trick which allows it to look like declarative or kind of more like a block diagram is that, and it's a big trade-off because it means that something is happening auto-magically, which runs the risk that students will be confused by it in the future. But I think it's worth the kind of trade-off. There is, so because there's a debate, this is actually a big question, possibly the biggest in the design of the language, is should processing be explicit or should it be implicit? It's great what it looks like when it's implicit, and every kind of different variation of making it explicit I've tried has a problem. The least worst option is to overload the logical not, or there's kind of the tilde, basically. So the unary operator, I could, for example, put that in front of, whenever I want it to process, you could put the tilde in front of it, which kind of feels quite Max-like and kind of, or MSP-like. And then, for example, if it's got a tilde, it processes. If it doesn't have a tilde, it returns the last output of it. It also tended to make the code pretty messy. It also, for that person, when they first see that, they're going to see, what do all these tildes mean? So, yeah, I ultimately will probably end up with a default behavior, which is implicit. And then maybe you can set a define or something up here before you include Klang if you need it to be more explicit. It depends. What's the view in the room? Do you think the kind of implicit, explicit? Who votes for having it no symbol? Okay. And who votes for having some form of explicit call? I saw that. Yeah, welcome to my world. So you're for the switch then. Yeah, it's tricky.
It's the type that then you have to use.
I mean, ultimately, there are other use cases where you have to, other things you might want to be ticking or not ticking. So that just happened to be the one I stumbled across. Anything, so oscillators, envelopes, filters, You don't want so like, filter's a classic one, which got a state, and I think, well, my student wants to, use this filter, but then I also want that filter signal to go to there, or even better, I know I'll just use the same filter for the left and for the right. So I kind of got around to the realization that this is probably a learning stage I'm not going to avoid.
One thing you could probably do, which is, I'm not sure how you hide it in the language, if it's the idea that everything should tick over in its state after you've called process, I wonder if an RAII type structure, which is to say I've touched something, now there's an implicit temporary variable that's been created, and after I leave the scope, because I've finished everything, now it just kind of moves everything to the next level.
When I first came across this problem, that's where I immediately went, and I can't wait. And basically the problem is you can't do that without really complicated code or extra lines of code where the user has to tell, when do I reset the counters? When is the start of the buffer? And so when it leaves the scope, it made it a lot more complicated, and it created bigger, worse problems later on. I've not given up on it yet, and I'm totally open to suggestions. But yeah, they're kind of like having a kind of a global kind of tick manager or something like that. And as long as that's at the right point, unfortunately, it has to be every sample. You tell that tick manager to reset. And I think, well, suddenly, if we're doing that amount of extra processing every sample, that could have a significant performance penalty, and it's no longer the same as C++. Yeah, difficult. Very, very difficult.
So just to follow up on what I was asking before, because you removed the ++, if you wanted to advance it without using it in an audio signal, you'd have to do some other casting it to a float to trigger that tick?
That's a very good question. No. So basically what happens is that these objects have the same kind of topology, the same kind of architecture. So they each have process functions. And those process functions have no inputs or outputs. They just work on the internal variable, the in and the out. So if you wanted to trigger processing explicitly, you could go osc.process, and that would trigger the next out, basically.
Right.
So you could be very explicit
just
about it. Yeah.
.process.
And that might be a way of avoiding the problem later on when the students start to get to this. Well, now we have to explicitly think about processing and then whatever. But yeah.
Because I was thinking of maybe a sort of overly hypothetical example, but like we're talking about envelopes here. You've got two envelopes, and then you've got some switch between them, and you've got an if statement. You're branching and choosing which envelope you want to be using.
Yeah.
But you want to keep the envelopes in sync. Yeah. So you would say, audio signal, use envelope 1, but envelope 2 .process, and that would keep the ticks advancing.
Yes.
But using one.
Yeah, process would work. They might be tempting to put like in your branch. You do write a statement which says, okay, this is a signal which uses the signal the envelope that's not in use, and we'll just put it in a variable so that it triggers. It's very likely that the compiler, because it sees that it's not being used, will just optimize that out, and therefore you actually won't achieve your goals. And that would be the same as if you timed it by 0, for example, potentially. That shouldn't be optimized out because it involves a state change, but. Yeah, there are solutions to it, but it's not hypothetical. You named a case where that'd be the case. Yeah, you can just call process, basically. Or you can use it in some way, you can times it by 0. Great, right. So in this section, basically, we've got about 40 minutes left. We've just gone through this. There are several other cards there. Tell me what you would like to do. Basically. So the other cards only have some of the code, okay? And the key bits of the code are missing, and the idea is that you can work, or we can work, to fill in those. And I'd like, basically, this to be a little test of whether I'm the only one this is intuitive to, or whether you also can work out what's going on, because if you guys can't, then my students are screwed. In broad order, the next simplest one is the ping pong delay. And then the other two are a bit cheeky. The supersaw, which has a really scary block diagram, but the code is a lot simpler. Okay, this is kind of proving the value of code and abstraction, and especially for loops, or the pluck string. The pluck string is not too bad. It is entirely up to you which you'd like to do, and whether you'd like to have a go at trying to do them by yourself or in groups, whether you'd like to do one more and then have some exploration. Please do feel free just to jab at it while I prattle away and come up with different things and whatever. What would you like? Would you like another kind of, maybe do the ping pong as a kind of class?
Quick question.
Yeah, absolutely. Yeah.
Got lost. So what is the 32 you're passing to the note add?
The number
Why
of
does it-
instances of notes, so basically that equals the polyphony. So this synthesizer has 32 note polyphony.
Okay, that's what I assumed, and the stop is what should be. Yeah, I'm noticing if I pass like 2 or 10, I don't seem to get any notes out of the synthesizer.
I think that's a bug.
Okay.
Which one are you on? You're on Mac. Yes, I've been messing about with that with the WebAssembly, because quite a lot of the time WebAssembly can't do 32 notes, especially when I throw 80 saw oscillators at it, which is the THX sound. That's a bug, definitely, and I have come across that myself. Yeah. Yeah.
Let me get my notes down.
If you can work out why it doesn't work and fix the bug, excellent. Cool, right, so let's do the ping pong exercise. There's a few different things about this. First of all, you need to switch over to the effect. So if you go to the main kind of door and go for mode and just click effect, there might be a slight pause, maybe a slight crash. Usually it just takes a bit in your own time. And so a few things are going to be different about this while that thinks about its life choices. Here's what we're looking at. That's the code that you want to start with, basically. But, and I do need to create a new thing, you go to the project tab, click plus, give it a sensible name, or a personal name. There is already a ping pong example in there, so you might want to call it something different. But
I think you have to name the module the same as the struct, right?
It does it for you. Yes, it will do it for you. So you'll end up with whatever you called it, and then you just need to fill in the constructor bit and the 2 lines in the process. This is an example of how to kind of group your controls. So here, because we're a stereo plugin, there is also one big other difference. We need to add the word stereo in front of effect. What effects does that have? It means you now have access to a stereo signal type. So we're using that down here. So it's just like a signal, it's float-based, but you'll never guess what, there are 2 of them. Okay, so you access each part of it by going time.l for the left or time.r for the right. All right, and now I'm just going to switch this off and switch it on again. Dink, dink, dink. Where's my file? There we go. The pitter-patter of tiny keys. It's like a granular synthesizer. Okie dokie. Right. Yep, awesome. So I am somewhat conveniently perfectly set up for this exercise. It's almost like I planned it. So I need to change that to delay, that to feedback, same again. Okay, let's get it to the state there. We don't need the prepare function to keep this nice and simple. I'll just return that to that very, very popular plugin pass-through. Okay, let's build that, just make sure I haven't made any mistakes. Let's make it big. Let's remember. Okay. So I'll make it stereo. And down here. So as soon as I make it stereo, in and out now have left and right. Oh, I might need to build it. Yeah, because I built it without that in there. So now it should be channels. Oh, for some reason it's not listing L, but I show you it's there. And it does have a kind of, I could put in into the out and it would be exactly the same as that. So that should work. So how you go about this exercise, there are lots of different solutions. We could just treat it as 2 mono channels. So let's do that first. It's a ping pong delay, as you'll see in the block diagram. We need 2 delays. So let's declare 2 delays. Okay, and actually in the block diagram, I've called them left and right. So rather than using an array or anything like that, we'll just, you call one left and one right. This number here is basically the maximum number of samples that are allocated in memory. So nominally that's up to a second, they're kind of 192 kilohertz possible sample rate. Okay. And let me just write those 2 other things down here. And just catch up with you guys. Gesundheit. So what I think I'll call it gain. And that's 2 and 3. Yeah, that's a typo. Which ones are we talking about? Which the closing brace, the squiggly brace. Oh yes, you're absolutely right. Those are superfluous. So yeah, yeah, they can. I will actually make a note of these. Right, thank you. So yes, well spotted there. So the 1 and 3 was correct. It was the 1 that was wrong. Okay, so yeah, do what I do, not what I write. If I give you that. Okay, how are we doing? So now we can access the left time value with .l or the right time value with .r. And if we look at the block diagram, we want to calculate the feedback signals. Okay, there's 2 ways you could do this. We could have a mono signal for feedback L and work it out. Or we could have a stereo signal called feedback. And then we say the feedback for the left. Oh, yes. Okay. So over to you, basically. As per the block diagram, the feedback is the output of the delay times by the gain value for that side. Okay. Anyone got a thought or how it might work? It's not hopefully a trick question.
The signal.
Stereo signal has two aspects, and you can access the individual ones by going .L or .R. But if you want to do it as mono signals, that also works. So if you just want to have like a normal mono signal, and we say feedback left equals, we can do that too. So what goes here?
Feedback left would just be the delay and just
Yep.
in left goes to it to go to the right.
Yeah. So as exactly that. So we have basically the output of the delay times the gain is the feedback signal, right? So how do we write that as, well, we called it left here, didn't we? Times gain left. Okay, and the one thing we do need to do is tell the delay how long it should be, which we'll just pass it in brackets. Where does that come from?
The control, the time 0.
Yep, time left. And that's in seconds from 0 to 1. So how do we convert it to sample rate? Sorry, how do we convert to samples? I'll just give you the answer. Times it by the sample rate, which is just fs.
That's the two-point thing.
Yeah, that's a very good question. Have you got one of the?
Yeah.
I think I've stashed it here somewhere. Is there a constant section? No. You probably can do this. Yeah, there you go. So if you just do the Klang workspace, you get the autocomplete after the double colon, you'll get a list of the globals that are available. And FS is there, along with a lot of that. Right. I'm not going to insult your intelligence by saying how do we work out the right. Change all the lefts to right and all the L's to R. Okay.
Is there a reason you didn't use stereo signal?
Just because I could. But absolutely, I would be very tempted to do that. So I'll create a stereo signal called feedback. And then I can go feedback.L, feedback.R. Another way of doing it. Okay, so there's our two feedback signals. Yes.
But there's no way to compose this so that like you have like since you like have a stereo delay that you're passing a stereo signal with the call operator.
There absolutely is. I'm just doing it this way for why not? But you could just go and you get a stereo delay.
Oh, okay. So but you can't like take two delays and make a stereo signal because you lose the call operator then, right?
It will work actually. I'm just so basically what you do here is you can just write this.
Oh, right. But what I was asking is it's not possible to create 2 mono delays and then later in your process compose them as stereo.
That's a good question. You could with an initializer list. So let's go back to that. There's your mono delays. And then you could do this. Is this a bit more like...
Oh, yeah. So that's what I was seeing. Yeah. So yeah, essentially but you're still using the call operator on the mono ones because the stereo signal has no call operator.
That's right. Yeah.
Okay.
You can't cast them to get the stereo capability. Not yet. I haven't worked out a way yet. But you could, as I showed, you could create a stereo delay, in which case it just does it for you, basically. Okay. Make sense to everyone? We're good? Now, obviously, we're not doing anything other than passing the input to the output here. Basically, however, we've done all of the block diagram with the exception of the 2 mixes. Okay, so we've got our feedback, we've got our ins, so we just need to extend this. What should I write here? What do I add to? Yeah. Because I hope this works when I press build. And feedback left. Okay, let's click build. This is the beauty of, oh, so it hasn't, it's compiled. Is this stereo? I can't tell from here. Oh, hang on, there's.
How do you read the bass?
Oh, yes. Oh, well, that's simple enough. So in dot left, very good point. That is one part of the block diagram, so it was right there. Delay dot, actually we called it left, didn't we? And in dot right goes into...
After you do the... Doesn't make sure either. That's what the block diagram shows. Block diagram shows it's...
Oh, yes. Oh, yes, I've done a feedback. Fair enough. That's also easy to do. So was it left? Out L, right, out R. No reason why you have to go right to left there. You could go left to right, but it is just replicating what you see in the block diagram. So you could also just write that as...
And the order of that left-right on those doesn't matter. Could you feed it first to the output and then back just to...
Yes, you could, because the out is stored from the previous time around, it's effectively the same variable. Yeah. And so that's part of the beauty of actually having that return value persist until next time. It becomes very, very easy to write things like filters, a couple of strong model strings and things like that. Okay, let's give it another go. I am only hearing this speaker, so are you getting a stereo image? Yeah, cool. Something in the middle. How about online? Is that stereo? With delay. And now with feedback. Very difficult to code stereo effects in mono or near one speaker. All good? Any questions about that? So as we talked about before, we could also make this a stereo delay, which simplifies the code a little bit. Of course it helps if I don't call them left and right.
Are delay time changes smoothed, or should smoothing be implemented in a different way?
Great question. So obviously, as I can demonstrate now, if we change the delay time, we're going to get clicks as we move about in the buffer. So we want to smooth. The way to do that is when we access the control value, there's a built-in smooth function, which basically applies a low-pass filter and smooths between them. Obviously, that won't solve the problem because we'll just get pitch. Which I don't need to do it there. We'll get pitch of artifacts, but we don't get glitches anymore. So if we play, so no glitches anymore. If you want a really funky ping pong delay, the one built in has a few more features. And some presets. Yeah, this is why I go down rabbit holes when I'm coding this thing now. I just go into flow, basically. Cool. Any questions? Make sense? How do you feel about that? Is it, so looking at this code, I'll go back to the code.
Some thoughts. So I take it that time is the stereo signal for time and gain. Are they like vectors of values? Or can I think of them as scalars? Like how should I?
So actually what the stereo signal is just a type def of the signals type with that. So you can use that for any kind of multi-channel signal. And so you could put 4 in there and have a 4-channel signal. But what it has effectively is the first 2 channels are always going to be available also as left and right. Then the other channels have to be accessed. I'm not going to call it signal. That's a bad idea. So I'll call it Kevin. So yeah, basically it's an array inside. Could be a vector potentially. And then you can access the channels. I think it's got, you can just do that basically. But for the first 2 channels, there are also, it's a union reference basically to the first 2 elements of the array. So you can also still use left and right. I haven't named any after that because the formats always change. So.
I think that's fine. Like, but it is, so it's really the like sort of first second of a pair sort of idea,
yeah.
like
and then just because stereo is a common case, it's type defed it. And there are some functions and operators which are specially written for the stereo signal.
And for the controls, the declaration there, for me, when I see that declaration for controls, I would almost see like a nested sort of way of accessing it. So if I wanted to get time, my natural inclination would be controls of 0, 0.
Yeah.
And sort of things.
I sympathize with that a lot. And OSC obviously is very hierarchical and is very powerful because of that. What this is kind of the left and the right are just UI elements rather than presentational elements. And they basically get ignored. They basically get put in a different descriptor of how to group controls rather than a tree structure. I think there was a reason I wanted to avoid tree structures just because of the CABI and communicating between different libraries and WebAssembly, and just keep it really, really simple in binary format. And so what you end up with is a lot of arrays rather than more abstract or variable types.
I think in the C++ code, you could do some sort of mapping lookup where it overload the string operator for the lookup and then be able to give it the name right and left and then maybe access it in a little clearer of a way.
Yes, I could do that as well. And I do like the idea of, so down here, of going delay. I don't see any reason off the top of my head why I couldn't implement that over the top of the existing structure. So I've always looked for a use to overload the comma operator, and I've never
Oh, no,
found
no,
one.
no.
But maybe you could have something like that. I don't think I like it that much. I think I like it
Fiendish.
almost as much.
Fiendish. Yeah. So put it in right now.
Or there could be, I could do this, for example, also potentially. Yeah, I think that makes this more C-like thinking, or maybe something even a little bit nicer. I mean, if performance isn't an issue, you could have that and then pass it perhaps, but ideally you want it to be able to be worked out at compile time. And so it's performative rather than having to do string matching and loops and things. But, you know, C++, there's probably some feature of modern C++ in there that can do exactly that. Thank you so much for joining me at the workshop and for excellent feedback for version 0.8. Please come up to the conservatory in the next couple of days where we've got a variety of these different projects. You can play with this. You can also play with the Manhattan project. Not that Manhattan project, but there is a certain amount of destruction involved. So that's about procedural music and a programming language for that. But there's also a Unity game where you get to kill an orchestra. So yeah, a little bit of fun. You won't miss me. I'm in the corner making a lot of noise.